Let's continue with the bivariate function z, which is a function of x and y. The cross partial derivative is a double partial derivative, in which first we take the partial derivative with respect to one of the two variables, either x or y, and then taken with respect to the other variable. For example, in the case of zxy, this means that first we will take the derivative with respect to x and then with respect to y. In this other case, first we will take the derivative with respect to y and then with respect to x. In addition, in cross partial derivatives, there is an important property known as Young's theorem, in which if the function is differentiable, then no matter the order of the derivation, the result of the cross partials z xy and z yx will be the same. To illustrate how the cross partial derivative is computed, let's solve the following example, in which we need to compute the second and also the cross partial derivatives with respect to x and y. This means that we will need the double partial derivative with respect to x and with respect to y, and the cross partial derivative with respect to x and then y, and then with respect to y and then x. Notice that in order to obtain the second partial derivatives, first we need the first partial derivative. So let's compute z with respect to x first. Notice that in this case, x is a variable and y is a constant. In the first case, the derivative of 4x to the fourth, first we need to recognize that 4 is a constant times the derivative of x to the fourth with respect to x is simply 4x cubic plus, for the second term, 5 and y cubic are the constants times the derivative of the variable part, which is x squared. The derivative of x squared with respect to x is 2x plus, notice that the last two terms don't have x, therefore the derivative is simply 0. So this means that zx is equals to 16x cubic plus 10xy cubic. Let's continue with the derivative of z with respect to y. Now notice that y is the variable and x is the constant. The first term, which is 4x to the fourth, there is no y, so the derivative is 0 plus. In the second term, the constants will be 5 and x squared times the derivative of the variable part, which is y cubic with respect to y, is 3y squared plus the derivative of 8y. In this case, the constant is 8, the variable part is y, and the derivative of y with respect to y is 1. Plus the derivative of 7, which is a constant, is simply 0. This means that zy is equals to 15x squared y squared plus 8. Now we can proceed with zxx. This is the derivative with respect to x again. Here, the constant part in the first term is 16 times the derivative of x cubic is 3x squared plus in the second term the constant part is 10y cubic times the derivative of the variable part, which is x. With respect to x is 1. This means that zxx is equals to 48x squared plus 10y cubic. Now, in the case of y, the double partial derivative is, notice that the constant part is now 15x squared times the derivative of y squared is 2y plus the derivative of 8 is 0. This means that the double derivative with respect to y is 30x squared y. Now, let's take the partial derivatives. But in this particular case, the cross partial derivatives. Because we already did z with respect to x, now we will do the other derivative with respect to y. Notice that in this case, if we do with respect to y, this first term does not contain y, so the derivative will be 0. Plus, notice that here, because we will take the derivative with respect to y, the constant part is 10x times the derivative of the variable part, which is 3y squared. This means that zxy is equals to 30xy squared. Let's do the same here. Let's find the cross partial derivative. Because we already took the derivative with respect to y, in order to find the cross partial, we need to take the derivative now with respect to x. Again, notice here that in order to take the derivative with respect to x, y will be constant. So here, 15y squared is a constant part times the derivative of the variable part, which is 2x, plus the derivative of 8 is 0. This is zy x equals 30 x y squared. And notice something interesting. Both cross partials are the same. This means that no matter the order, if we take first with respect to x and then with respect to y, we will obtain the same answer as taking first x and then y.